Welcome to Mr. Leek's free science tutorials. Now, this question that we're dealing today is describe the penetration power, the range in air, and the ionizing power of the three types of decay. Now, in a previous video, what we did is we talked about what they physically are. You've got your alpha, beta, and gamma, and there is a fourth one that's sometimes talked about, which is then your neutrons. So what we need to do is the penetration power is how far it will go through something. The range in air is the distance it will travel in air, and the ionizing power is kind of like the damage that it will cause. Now, this is then a typical table and a typical diagram that you may well see of this question. You've got alpha, beta, and gamma. Now, if you remember, alpha is a helium nucleus, beta is an electron, and gamma is a wave of energy. Now, I always like to try and think about things and sort of picture it. A little bit to do with this. You've got alpha, beta, and you've got gamma. Alpha is basically four balls, right? Four balls out of the nucleus that have a reasonable amount of mass. So physically, it's actually quite big. Beta is a tiny, tiny little electron. You know, it's thousands of times smaller than the alpha particle. Gamma basically has no mass at all. It's just a wave of energy. Now, if you can picture them as like sizes like that, then it kind of makes a little bit more sense about their penetration power. Now, alpha, range in air, is a few centimeters, right? It'll literally go that far, right? Depending obviously on the power and stuff like that. But alpha goes a few centimeters. Beta will go a few meters, right? So across your classroom. Gamma can go great distances. Right, so if I set off some gamma radiation, it could go miles and miles and miles and miles and miles. Ionizing power is basically how dangerous it is. Alpha is very strong. Now, if you think about its size and it's hitting cells in the body, right, then it's much more likely that an alpha particle is going to hit something significant in a cell, therefore its ionizing power is very strong. Beta, ionizing power, is in between the two. So it's medium, so it could do something, but it's much less likely than alpha. Gamma is very weak because basically gamma is a radiation, it's a wave of energy, and what it'll do, it just goes straight through something. Penetration power is often shown as this diagram here. You've got alpha, beta, and gamma. Shine them all at a piece of paper. Alpha is stopped by paper. Now, if you think about it, alpha's big, paper's got the little fibres in it, and basically what will happen is the paper will kind of catch the alphas a bit like a net. Beta, because it's so small, goes through the paper, but then it gets stopped by aluminium, because aluminium is then denser, just like a thin piece of aluminium. Gamma goes through the paper, through the aluminium, and then it's actually physically stopped by thick lead, which is then why radiation sources that you might have at school or radiation sources that are stored in places, what they will have is they'll have a lead lining, and that lead lining will then prevent the gamma radiation coming out because the lead is very dense, stopped by thick lead. So the question, describe the penetration power, the range in air, and the ionizing power of the three types of decay. Alpha only travels a very few centimeters in air. Its ionizing power is very strong and it is stopped by paper. Beta will travel a few meters in air. Its ionizing power is weak and it is stopped by aluminium. Gamma can travel great distances in air. Its ionizing power is weak and it is stopped by thick lead. Sometimes people ask the question was, if you swallowed a tablet that had all three types of decay in them, right, which one would cause the most damage on the inside? Now, if you think about it logically, gamma is just going to come out. Beta, it'll cause a bit of damage. Alpha is going to get absorbed very, very close to where the actual radioactive substance has gone in, and it's going to cause a lot of damage when it actually goes inside. So that answers the question. Describe the penetration power, the range in air, and the ionizing power of the three types of decay. Alpha, few centimeters, strong ionizing, stopped by paper. Beta travels a few meters, medium ionising, stopped by aluminium. Gamma can travel great distances, ironing power is weak, stopped by thick lead.